Good morning. Happy Tuesday. We are going to go over some homework problems first. I don't want you to think that a lot of you miss these problems, but I wanted to go over those of you who have been consistently doing the homework. If you missed one, I want to go over it. Okay, so all the ones that are blank are the ones we're going to go over, and then the ones that are already done are ones no one missed. Okay, so let's discuss. All right, this first one is a rectangular prism. Okay, I know I just said prism. Sorry, it is not a prism, it's a pyramid. The way we know it's a pyramid is because it comes to a point, and then we know it's a rectangle because of the base. Okay, so the first thing we want to do is we want to find big B, which is the area of just this flat base. So we're going to do length times width, 4 times 8, which is 32. Okay, once I find big B, now I can plug in the formula. So the formula goes 1/3 big B times the height. Okay, and so we're just going to go pretend it goes straight across like that. And then we're going to type in 32 times 8, which is 256 over 3. Now, some of you actually divided by 3, so I'll put or. Okay, and then our unit was yards cubed. So either of those two answers is appropriate. Okay, here's number 2. Nobody had trouble with that one. All right, number 3 is a tough one. It is a triangular pyramid. It comes to a point, and then the base is a triangle. All right, so there is a distractor in this problem. It is actually a right triangle pyramid because the right triangular pyramid because the base is a triangle, a right triangle at that. So I want you to understand that this 10 is the hypotenuse. It is unneeded. So this is your base, this is your height, and then this is your height of your whole pyramid. So when we do big B first, so we're going to do 1/2 base times height. Remember, that's the area of a triangle, just this triangle here. We're going to do 1/2, and you guys, the base and the height can be switched around. So the 6 could also be the base and the 8 could also be the height because multiplication is commutative. So we'll do 8 times 6. And then that gives me 24. Okay, so now I can plug in the formula. So the formula goes 1/3 big B and then the height of the pyramid, which is 6. All right, and then we can type that in, and that should give us 48 feet cubed. So I did 24 times 6, which gave me 144, and then I divided it by 3. Okay, so there's that answer. All right, here's this answer. Some of you left it as a fraction, some of you put it in decimal form. Either one is fine with me. I prefer fraction, but I wouldn't count it off if you did it that way. Okay, here are these answers. All right, let's talk about the trick with number 6. This is the diameter, so I don't want the diameter. I want to divide it by 2, so the radius is 4. Okay, so volume equals 4/3 pi r cubed. All right, so then I'm gonna kind of go like this. So I'm gonna do 4 and then 4 to the 3rd power. So that's 256 pi over 3. If you divide that by 3, it doesn't come out nicely, but some of you left it like that. It turns out actually to be just like number 1, the answer. Okay, so either of those is okay with me. All right, so now that we've done number 3, number 8 is very similar. So this is a triangular base, and it's a right triangle. So this is like your base, and this is like your height, or you could switch those around. This is a distractor. You don't need that. So to do big B, we're going to do 1/2 base times height. So that's 1/2 times 6 times 8, which will give me the same exact thing as before, which is 24. All right, that's my big B. So now I can plug in the formula. Oops, I was about to put 4/3. 1/3 times big B, and then the height is 9. And then that should give me a nice whole number. So 24 times 9, I'm not going to write this down because I don't have enough room, is 216. And then divide 216 by 3 and you get 72. Okay, so there's that answer. All right, number 9 is, there should not be anything too complicated about this one. So 1/3 pi r squared and then the height. It's not a trick question because the 24 is actually pointing to the height. The cone's just kind of tilted over on its side. So think about turning it sideways or upward, and then you would have this being the radius and this being the height. Okay? So I'm just going to kind of extend this over, and I'm going to do 12 squared, which is 144, times 24. And then I'm going to divide that by 3, see if it divides, and it does nicely. So our answer is, okay. And then number 10 has a little bit of a trick because this is the diameter, so we want the radius to equal 4. We just have to divide, okay? So for the volume of a cylinder, it's just pi r squared and then the height. Again, this is like a Pringles can on its side. Okay, so you want to turn it up, like flip it up, and then I think you could see it if you flip it up mentally, excuse me. And so now we're going to do 4 squared, which is 16 times 9, and that should give us 144. And then we have a pi, and then our units was kilometers. Okay. All right, so now, again, number 11, this is the diameter, so the radius is going to equal 9, and then this will be our height. So volume equals 1/3 pi r squared, and then our height. Y'all, sometimes I put parentheses, and sometimes I just put the dots. I'm sorry, I'm being inconsistent. You know, it just means multiplication. It doesn't matter how you use it. All right, so 9 squared is 81 times 18, which gives us a pretty big number. And then we'll see if we can divide it by 3, and we can. So our final answer is this. Okay. And then our last one is a square pyramid because the base here is a square since both of these length and width are the same. So big B is just going to be 3 times 3, length times width, which is 9. And now I'm going to do volume is 1/3 big B times the height. Which is 5. Okay. So I'm going to type in 9 times 5 is 45. 45 divided by 3 is 15. And there's your answer. Okay. So if there is anything you have questions about or anything you can, further than what I've explained, just let me know. Okay. Okay, so today we're going to talk about composite figures. There's a warm-up on this, but you don't have to do it. It would be like EOC practice if you're going to print these out. All right, so a composite figure is basically where we're going to take 2 or more of our shapes and we're going to put them together, or maybe take them away. We'll see. I'm going to try to show you examples of both. Okay, so we have a house here. If you take this part of the house, that is a triangular prism. Now, I told you guys that we are not going to be doing triangular prisms, but that is a triangular prism. Okay, it doesn't come to one point, so it's not a pyramid. And then the base of the house, like the bottom part down here, is a rectangular prism. So if we wanted to find the total volume of that house, we would do like the triangular prism and the rectangular prism, add them together. It'd give us the total volume. All right, so an ice cream cone is made up of 2 parts. We have this part here. Now we could debate if this is a sphere or a hemisphere. You know how ice cream typically like dips down into the cone, but we're just going to pretend it like sits right there on the surface. So a hemisphere, which is, half of a sphere. You also could say sphere. I'll be very clear when, we talk about these. And then the bottom one is a cone. So if we wanted to know the total volume, we could add the two of them together. All right, so this hopper bin, like if you've seen that driving by like farmland or whatever, it is made up of two parts. So we have this middle part here. Yesterday I was drawing shapes outside with my son with sidewalk chalk. That was comical. You should have seen it. Okay, so that middle one is a cylinder. I think everybody can tell that. And then what are these things here at the top and at the bottom? Those are cones. They're just wide cones. Okay. Now you may not have known this. I didn't know this until I saw it on I think it was like How It's Made or something like that, one of those shows. So a cup is actually made where you take like a big cone. See the full cone right here? It's a big cone. And then we're going to cut out or cut off this small cone at the bottom. Okay? So if you take a big cone and you cut a smaller cone, it's actually going to give you the cup. Obviously you have to put the bottom, like the base in the cup, but so it's made from cutting a small cone away from a larger cone. All right, and then if you have like nuts and bolts, to build something, to kind of put things together, screw things together, the nut is actually made from cutting out this part, that cylinder. So that's a cylinder from okay, now let's look how many sides this thing has. So it has 1, 2, 3, 4, 5, 6. So what is a 6-sided figure called? It's called a hexagon. Just a flat one, but this has height to it. So it's called a hexagonal prism. Now, don't you worry about that because that's kind of accelerated, if you will. We are obviously not going to do problems like that. We're going to kind of keep them simple. Okay? So we're going to do 3 problems together, and then y'all are going to practice a few on your own. Okay, so we have a pencil. And we need to figure out, first of all, what are the figures that are used to make the pencil. We're going to decide if we need to add or subtract them, and then we're going to calculate the individual volumes and then do what we thought, add or subtract. Okay, so a pencil is made up of, so let's discuss, this big part here is a cylinder. And then the little tip, this part, I guess I should do it a different color. This part is a cone. Okay? Now, are we putting those two shapes together or are we subtracting them? Well, we're putting them together, so that means we're going to add them. Okay? So we're actually going to do the calculating. So I'm going to draw like a line. We're going to do cylinder over here, and then we'll do cone over there. Okay? So the only thing that's going to be slightly different here is instead of leaving the pi symbol, I'm actually going to plug in 3.14 for pi. So y'all know pi is approximately 3.14. So that's what we're going to be plugging in so that we can actually add the volumes and have an approximation instead of kind of leaving it with pi in there. Okay, so the cylinder formula goes pi r squared h. So we're going to put 3.14 times, okay, what's the radius of that cylinder? The radius is here, 0.5 centimeters. And then our height is, let's, instead of doing dots, let's do parentheses, so it doesn't get confusing. And then the height of the pencil is here. Well, it's not of the whole pencil, it's just of the cylinder, is 15. Okay, so let's just type this in. Now I'm going to put approximately at this point, okay? So I'm just going to literally type it in like I see that. I'm going to type in 3.14, parentheses, 0.5 squared, parentheses, 15, and then hit enter. I just have to make sure I put the parentheses and everything. All right, and then what was that unit? Centimeters cubed. All right, for a cone, the volume is 1/3 pi r squared h. So we're going to do 1/3 3.14 The radius is still the same radius as the pencil, because you see it's like the same width here as it is here. Okay, so 0.5 squared. And now the height of the point or the cone is only 2 centimeters. All right, so I'm going to type in all of the numerator first. So I'm going to do 3.14 and then 0.5 squared times 2 is 1.57 and then divide by 3. Okay, so that is what we have approximately. Sorry, I was just checking my work. Okay, it's very small. It's a small volume because we have a very small, pencil. And honestly, this is probably a little bigger maybe than what a normal pencil is. All right, so now what do we do with these two things? We said we were going to add them. So we're going to go 11.775 plus 0.523, and we have approximately what the volume of the pencil is. So 11.775 plus 0.523. And our unit was centimeters cubed. All right, so y'all see what we did there? We found the individual volumes and then we just added them together. All right, so we're going to do another one, snow cone. So this one is not like ice cream. It's like what you get at Pelicans, or I can't think of any of the other names, but Pelicans is the one that I think of and know the most. Oh, Kona, that's it. Pelicans or Kona. So we are going to pretend that this is just a hemisphere, okay? So we're going to do hemisphere and then a cone. Oops, I forgot the E on the end, sorry. Hemisphere. All right, so we're literally going to take that it stops there, and goes up like this, okay? So are we going to add or subtract them? We are going to add them because it's both of those put together that makes a cone. And then let's take a look at the figure. So the first thing I want you to understand is that's the diameter. So that means the radius is going to equal 9, okay? And then here's the height of our cone. All right, let's draw. We're going to do hemisphere. I'm going to abbreviate hemi, and then we'll do cone on this side. All right, so if y'all remember from the notes yesterday, gosh, was that yesterday? No. Thursday or Friday, we talked about hemisphere is just half of a sphere. So instead of the volume being 4/3 pi r cubed, it's 2/3 pi r cubed. Okay, so we're going to have 2/3, 3.14, and then our radius is 9 cubed. And so I'm going to type in the numerator, so just 2 parentheses 3.14 and then 9 and then caret 3, which gives me 4,578.12, and then I'm going to divide it by 3. I'm going to do approximately 1,526.04 centimeters cubed. Okay. All right, now the volume of the cone is 1/3 pi r squared h. So we're going to do 1/3, 3.14. Our radius is the same because it's not like it's going over, spilling over anything. Squared, and then the height is 12. So I'm going to type in all of the numerator. 3.14, 9 squared times 12. I get 3,052.08, and then I'm going to divide that by 3. All right, and now I'm going to take those and add them together. All right. So you see how this really isn't that hard of a concept? I think the hardest thing is like knowing what it is that you're adding together. Making sure you identify the shapes properly. If you can identify the shapes properly, it's not so bad. Okay, so that's ugly. I'm going to just leave it like that. All right, so that's our volume. All right, and then lastly, we're going to do a flag holder, or kind of like a, pencil holder or something like that. Kind of like, you could think of it as like a paper towel roll or a toilet paper roll, like that. Now, this is very hard to see, but this is, the diameter is 3 inches. And then the diameter of this is 1 inch. And then the height of it is 5 inches. Okay, if that's hard to tell. Now, because it's cut out, can y'all see that, like, this is where the flag would go to be held, like on a desk or something. So there's a hole in it. So if there's a hole, that means we have cut something out. All right. So in this instance, this is where we're going to subtract. So what is it that we're punching out or subtracting out of that big cylinder? Well, can you tell it's just a smaller cylinder? Okay, so it's going to be a big cylinder and then a small cylinder. So I wanted to show y'all one example where you're actually going to subtract. Okay, so let's do the big cylinder first. We're going to do volume equals pi r squared h. Okay, so we're going to have 3.14. Now, of the big one, this is the diameter. So that means the radius would equal half, and that would be 1.5. And then the height of the whole big, and what I mean by the whole big is this guy, right? Like this cylinder. Okay, that's what I'm doing. And the height of that is 5 inches. Okay, so I'm going to type that in. 3.14 parentheses 1.5 squared, and then parentheses 5. And that is okay. And then for the small, it's going to practically be the same thing, except for the radius is only the thing that's different. Okay, so volume equals pi r squared h. So 3.14. Now the radius is not 1, that's the diameter. So that means the radius would be 0.5. And the height is still 5. It's the same height as the big one, it's just a smaller radius to punch out. Okay, so and that is approximately 3.925. All right, so now we're going to subtract. Now we want to make sure we start with the large one so we don't have a negative number. And we're going to subtract out this small amount, and then that should give us approximately the volume of that flag. Okay. All right, so there are 3 problems, 2 where you add and 1 where you subtract volumes in order to find composite figures. Okay, so your homework is here. Now I want to go ahead and say, be very careful. 1 through 5 are just plain old figures. They're not composite figures. That's just more practice on what we've already talked about. Okay, let's say for 1 through 5, let's say leave pi. Leave the symbol pi in your answer. And then for 6 and 7, use pi is approximately 3.14. Okay, so 6 and 7 are your composite figures. On number 7, let's assume this is a hemisphere, okay, instead of a full sphere. Just FYI. All right. So you are going to try those 7 and respond to me, and then we're going to kind of put it all together and practice over the next couple of days. All right, y'all have a good one.